All right, today we're diving into a real cosmic mystery. It's a total head-scratcher that came to us from the farthest reaches of space, all thanks to the incredible James Webb Space Telescope. We're talking about the case of the impossible galaxies.
So, did the Webb telescope just break cosmology? I mean, for a little while, that was the question on every astronomer's mind. It's a pretty dramatic question, right? But for a moment there, it really seemed possible.
Because what Webb found way back in the dim, distant past were galaxies that, by all accounts, shouldn't exist. They were like cosmic outlaws, showing up where our best theories said they had absolutely no business being.
Okay, so let's get into it. We've got to start with the evidence, right? What did the James Webb Space Telescope actually find that got the whole scientific community so worked up?
Well, get this. Since it started its mission in 2022, the telescope has been peering back to the very dawn of time. And it's already spotted over 100 potential galaxies from the universe's first 400 million years. That's incredible. But as scientists started zooming in on these cosmic baby pictures,
They started to realize something was wrong. Like, really wrong. These were not the faint, tiny baby galaxies that everyone was expecting to find. Nope. They were something else entirely.
And the problems were just glaring. I mean, look at this list. They were too bright, too big, way too massive, and they just seemed too mature for their age. They looked like fully formed galaxies at a time when the universe was supposed to be, a cosmic toddler. How is that even possible?
So yeah, this wasn't just some small puzzle to figure out later. This discovery was like a giant wrench thrown right into the gears of our most basic theories. It created what some people were genuinely calling a potential crisis in cosmology.
And this is where you can really see the problem. The expectation, based on our standard model, was pretty clear. The early universe should have been full of small, low-mass galaxies just starting to form. A slow, gradual process. But the reality? What JWST actually saw? These huge, highly evolved-looking galaxies right from the get-go. It was a complete contradiction.
And the stakes here were, well, cosmic. This wasn't just about tweaking a formula. These findings suggested our standard model, the very bedrock of how we understand the universe, might have some serious cracks in its foundation.
But hey, if there's one thing science loves, it's a good mystery. So it was time to play detective. Astronomers started searching for clues to figure this whole thing out.
The first big breakthrough, clue number 1, came from questioning a basic assumption: how stars form. It turns out the way stars are born today in our nice, calm Milky Way, well, that's not how it worked in the wild, chaotic early universe. And this led them to this really cool idea called bursty star formation. So instead of a slow and steady production line, imagine stars forming in these short, incredibly intense bursts. A galaxy would suddenly just flare up, becoming super bright. This flash would make it look way more massive and mature than it actually was. It's kind of like a cosmic flashbulb going off, totally tricking you about what you're seeing.
Okay, so that bursty formation explains some of it, but it wasn't the whole story. Turns out there was another trick at play. Clue number 2, a powerful optical illusion happening right in the center of these galaxies.
So here's what was happening. You've got a supermassive black hole at the center, and it's just gobbling up gas like crazy. As all that gas swirls down the drain, friction heats it up to insane temperatures. The result? It starts glowing with this intense light, so bright that it completely drowns out the light from the actual stars in the galaxy. So what you see is this huge, bright blob that looks impossibly large, but it's really just the light from the black hole's dinner.
And you know what these things look like in the Webb images? Just little red dots. But here's the kicker. Once the scientists figured out which dots were these black hole illusions and took them out of the data, poof, the rest of the galaxies lined up almost perfectly with what the standard model predicted all along. Case closed on that part at least.
Okay, so the illusions are explained, but that still left a nagging question. How did any of these galaxies get up and running so quickly? Well, the investigation turned up let's call it a hidden accomplice. And this is where we get into the really fascinating role of dark matter.
Because even when you account for the bursty stars and the black hole light show, the timeline still felt accelerated. And a potential answer might lie with a very special type of dark matter that could have hit the cosmic fast-forward button.
This brings us to a theory called self-interacting dark matter, or SIDM for short. Now, the idea here is that maybe dark matter particles aren't complete ghosts. What if they could interact with each other a little bit
And even more importantly, what if they could interact with regular matter? The stuff we're all made of.
So, if this cydium existed, it could have acted like a cosmic refrigerator. By interacting with the hot hydrogen gas of the early universe, it could have helped cool it down. And cooler gas collapses under gravity way more easily, which means stars can form much, much faster. This would have basically cut the dark ages short and given those first galaxies a huge head start. So, let's wrap this up. What's the final verdict in our cosmic case? Well, it seems our universe is even weirder and more interesting than we gave it credit for. When you lay it all out, the case is pretty much closed. The things that seemed impossible, the brightness, the mass, they had real explanations. The initial fear that our whole model was broken, it gave way to a much, much cooler picture of what was actually going on. So our standard model holds. It wasn't broken at all, it was just stress tested. And it passed. This whole mystery didn't break cosmology, it just made our understanding richer, more detailed. It gave us a new appreciation for just how complex the birth of the universe really was. And that's the best part, right? This mystery is solved, but solving one puzzle just reveals new ones. You just have to wonder, as JWST keeps staring into the deep dark, what's the next impossible thing it's going to find?